Hello everyone, we are group 13 and we have only two group members, which are me and our group leader. Today our topic is about Spaceship Titanic Challenge. So before my presentation, I'm going to show you guys of our outline. So first is the recommendation systems that I'm going to introduce the origin of the Space Titanic dataset. Next, I'll tell you guys about our data preprocessing, including the process of importing and preparing the data before conducting any analysis. Next will be the method of evaluation, which I'll give a brief introduction to the algorithm that we use in our code, and that will show you guys about our evaluation and also the comparison of the accuracy of the results trained by decision tree and random forest. So, first, what is Space Titanic data set and where does it come from? It is start with a competition launched on Kaggle, and the competition is used to design as an update to the popular Titanic competition, aiming to assist individuals new to data science in learning the fundamental of machine learning and also connect with others in the community. So next is the data preprocessing part. The first step of it is data importing. So we first download the file to the local disk, then we specify the data type for the problematic column and also read the CSV file into our local disk. Next part is data splitting. So we split the cabin column into deck, norm, and slide. So before the splitting data, we will have only the cabin column, and now we'll get 3 columns after data splitting. So you can see that we print the data after we split it, so we get 3 different columns compared to the data set before we splitting it. So which is the data set we mentioned that we are going to split a stack, norm, and side. So you can see that we'll get deck, norm, and side, but we didn't have the cabin column. The third step is data filtering. So because we'll get a lot of data that we might not use or we have some missing decks, so this function is used to data filtering. So first, we identify the categorical and numerical columns. So we keep home, planet, critical sleep, destination, VIP, deck, and site to the category columns, and age, room service, food court, shopping mall, spa, VR deck into the numerical columns. Next is the pipeline for imputing and coding category columns, which is an also numerical transformer. So in the category transformers, we in the column of imputer, and when it is missing the data or index, we put the most frequent value into it, and in the numerical transformer we put the median number value into it. And the fourth part will be data merging. So after the data preprocessing, data splitting, and also filtering, we have to merge all of the data together so we can train our data later. So this is the applying train data and merge it together. So next comes to the math of evaluation. So first we use about the random forest, and the random forest have some of the features that I'm going to introduce to you guys. First is the badging. So random forest builds multiple decision trees and merge them together to get a more accurate and stable prediction. It does this by training each tree on a random subset of the data with replacement, and then averaging or taking a majority vote for classification problems from all of the trees. Next is the random feature selection. When it is building each tree, random forest introduce an additional level of randomness by considering only a random subset of features at each split. So this helps to relate the trees and ensures that each tree in the forest is trained on a different combination of features. Next, ensemble learning. The final prediction of the random forest is a combination of predictions from individual trees. In the case of classification, it's typically a majority vote, and in regression, it's an average of the predictions. 4. High flexibility of robustness. Random forest is a versatile algorithm that can be applied to both classification and regression tasks. It is less prone to overfitting compared to individual decision trees, making it more robust. 5. Handle missing value. Random forest can handle missing values well. When a new data point has missing values for some features, the algorithm can still make predictions by considering the available features. The last but not least is the OOB error. During the training process, each tree is not trained on all data points due to the random sampling with replacement. So the OOB error is the error rate of the model on the portion of training data not used during the training of each tree. It serves as a validation measure without the need for a separate validation set. So this is the code part of our random forest. First, we import the random forest classifier and initialize it, then perform the cross validation to evaluate the model and calculate the average cross validation scores. And in my memory, it's about 77% of the accuracy of our random forest prediction. So next, we'll have to train the model and on the entire training data set and make the prediction on the test data set. So also we finished that, we saved our data frame to a CSV file that we can handle. Next is the decision tree part that teacher have mentioned on the Kaggle. So I'll divide it into 3 related parts. First is random forest. As I mentioned earlier, it's an ensemble of decision trees trained on the random subset of the data and features. Next is the GBT, another ensemble method where trees are built sequentially and each tree corrects the errors of the previous one. Last is the ADA boost. It's a boost algorithm that combines weak learners, usually something like shadow trees, to create a strong classifier. So we make a comparison about decision tree and random forest with the same data preprocessing. So first we'll handle the missing values that will fill in the mean value when we have a missing index. And next, with the same encoding category variables and combine numerical and categorical data, and also repeat the same things. Then we'll identify the features and target variables. So we assume the transport is the target variable. Then split the data set into training and validation sets. And next is just put it into 2 parts. First is the decision tree model, and next is the random forest model. Then we evaluate both of them, then we can get the accuracy of both of it. The decision tree is about 77%, and the random forest is also about 77%, or you can say 78%. So in our opinion, we don't think that it have to difference apart each other when we only calculate one or a few columns or index things that we're going to use it to predict. So maybe we have to get a more bigger data set so that we can see the difference about two of the author. So thank you for your listening. This is group 13.